4.7 is about using isosceles and equilateral triangles. And we're really looking for what are the parts of an isosceles triangle and how are the sides and angles of a triangle related to each other. Isosceles, equilateral. Let's get into some examples that we've got to use these triangle definitions in order to answer the questions. In the given triangle, side DE is congruent to side DF. So DE and DF are congruent. Name congruent angles. Well, in this triangle is at least isosceles, maybe equilateral, but we don't know that for sure. If it's at least isosceles, then the two angles that are not included by the congruent sides, so angle E and angle F, are congruent angles. So angle E congruent to angle F. Those are the base angles. They are congruent. In this diagram, if we again look at angle segment congruence, segment HG congruent to segment HK, name two congruent angles. Well, if we block out this other part of the diagram, this is similar to just the last example, and that means these two angles are going to be congruent. So angle HGK is going to be congruent to angle HKG. Okay, so that's the congruence there. As a separate example, if angle KHJ, here's the angle KHJ, congruent to angle KJH, so now we're talking two angles are congruent, then what two segments are congruent? Well, by the converse of our previous statement, we're now looking at KJ and KH being congruent segments. So KJ congruent to KH. Okay, and that all has to do with isosceles triangles there. Okay, here's a triangle with notation showing that the two sides are congruent. Looks like we have an isosceles triangle, and we know that angle Y is 50 degrees. Find the measures of X and Z. Well, we know that these are actually congruent angles because of the isosceles triangle here. So what we really need is 50 degrees plus, well, this unknown angle here, we'll call it alpha, since X is already used. Well, alpha, both of those angles are alpha, so we've got two alphas plus the 50 degrees needs to get us to our 180 degrees for a triangle. So really 2 alpha is 130 and alpha is 65, and that's the measurement of each of the angles. Measurement of angle X is 65, and that's also the measurement of angle Z. There it is. Looking at this diagram, let's find AB in the triangle below. Well, based on notation, all angles are congruent. So this is an equiangular triangle. If all angles are congruent, then all side lengths are congruent. Given that BC is equal to 5, then AB must also equal 5, as does AC, equilateral triangle. Second question, is it possible for an equilateral triangle to have an angle measurement other than 60 degrees? And the answer to that question is nope. All equilateral triangles have 60-degree angles. Last example, find the values of X and Y. Based on the diagram, angles 1 and 2 are congruent. So we've got some congruent angles there. And triangle BDC triangle BDC is equiangular. Don't assume anything based on the diagram because that is clearly not an equiangular diagram. So go off of what's given to you, not the way the picture is drawn. So really, we've got congruence for these three angles, all of which have to be 60 degrees. We know that from the previous question. But that also tells us that if segment BC is 15, then we know segment BD is 15, and we know segment DC is 15. That gets us our answer for Y. So we have Y. Let's focus our attention on X. X minus 4, well, given that angle 1 and angle 2 are congruent, that's enough for an isosceles triangle here. It's at least enough to say that X minus 4, side BA, is congruent to side BD, which is equal to 15. So add 4 to both sides. That gets us X is equal to 19.